Here is the Atari VCS, Video Computer System, later known as the Atari 2600. I got it for $15 at the Midwest Vintage Computer Festival in September of 2022. The image shows the unit after restoration. As it was untested, I didn't expect it to work. After I disassembled it, I gave the two plastic parts a good wash. It wasn't that dirty to begin with. In fact, I only used water and a soft plastic brush to remove the accumulated dirt. I carefully brushed the grooves and every part of the case. This newer model of the Atari 2600 only has 4 front switches, whereas the older models have 6. Plus, the original model is physically heavier. The 2 missing switches have been relegated to the back, so they aren't really missing, just relocated. The first step in the restoration was to verify that the wall adapter was providing the right voltage to the unit. Looking at the adapter, I noticed that its output was 9 volts DC at 500 milliamps. This is the key if I needed to replace the adapter. Find one with a 9 volt DC output of at least 500 milliamps. I plugged the adapter into the AC wall outlet and measured its output with my trusty voltmeter. I got just over 14 volts DC on its output. This is high for a 9 volt DC adapter, but I considered that it wasn't hooked up to anything, so this test was done with no load. Some adapters output a higher voltage which comes down when a load is connected to it. Besides, if the Atari 2600 worked with 5 volts DC, then most likely it had a voltage regulator, possibly a 7805. So 14 volts DC was okay for this device. The voltage was steady, so I considered the adapter as reliable. Note the far right of the image. It shows the voltage adapter's connector. Typically this connector is a 5.5 millimeter barrel connector. The connector used here looks more like an audio connector. I recall that the Sinclair ZX80 also used a similar connector. I just hope no one is silly enough to connect this to an earphone jack. Time to open up the unit. After doing some research and a visual inspection, I located 4 screws. Older models have 6, so be aware of which model it is. 2 front screws are located towards the outer edge, and the 2 rear screws are in the elongated recesses. I used a Phillips head number 2 screwdriver to remove the 4 screws. Note that the rear screws are slightly longer than the front. When setting aside these screws while the unit is open, verify that the front and rear ones are not swapped. Once the screws have been removed, the cover just comes off. Lift it straight up. If stuck, move it around a bit or gently pry it. The cover might have to be rocked to loosen it from the motherboard. The video cable can be unplugged from the motherboard by pulling it straight up. Verify that the cable is grasped by the connector. Do not pull on the cable. Also, the bottom case has a cable guide and the cable should be pressed into it. Remove the cable from the guide. This frees the cable entirely and can now be removed and placed on the side. This is the motherboard. I have revision 16. Note that I left the video cable connected. In the image, it is located on the right side, just below the center. The metal box just below the video cable is the RF modulator. This generates the TV-friendly signals so that we can see the image on the TV screen. At the center is the RF shield. This box contains the electronics, such as the processor, 6507, and support chips. Left bottom is the regulator. As assumed, it uses a 7805 to generate a regulated 5 volts DC to power the unit. On both sides of the cartridge connector are the 4 switches. Note the metallic strip that connects both switches to the RF shield. This strip was placed there to minimize any possible damage due to electrostatic electricity. From what I've read, it didn't work very well. Also note the black dust rings. Each switch should have one. My unit came with only 2 of these. Finally, the row of switches and connectors at the rear are for the joysticks, power adapter, channel select, and other options. The 2 switches that disappeared from the front panel are located here. If the top cover does not come off easily, it is most likely that it is stuck on one of the rear switches/connectors. It might help if the front panel switches are shifted towards the front of the unit. Jiggling the cover usually does the trick. Getting a closer look at the RF shield, I noticed that it is held in place by metal tabs that are twisted to be at a 90-degree angle. I also noticed that some of them are just bent forward. If I need to remove the RF shield, I'll have to use pliers to grasp the tab and carefully untwist it. Since all the tabs seem to be twisted the same way, it looks like twisting them 90 degrees counterclockwise will align them with the slot and allow the cover to be removed. Now that I've opened the Atari 2600, the first task is to measure both input and output voltages. That takes us to the 7805 regulator. The 7805 has 3 pins. The one under the 7 is the input pin. Typically, the 7805 can have roughly between 7.5 to 30 volts DC applied to this pin. This voltage can vary among types of 7805s. Luckily, our measured input voltage without load was 14 volts DC, so this is perfectly within the range. The middle pin is ground. The pin under the 5 is the output voltage, which is 5 volts DC. The first and third pin is where I am going to take the readings. The 7805 typically can provide 500 milliamps up to 1 amp. However, it must have a heatsink to dissipate the heat. A rule of thumb is to keep the input voltage as low as possible. In this case, a 12-volt DC adapter would have worked, but a 9-volt DC adapter is better because it provides a lower input voltage. A 7.5 volts DC adapter would be ideal, but that is cutting it close to the minimum input voltage. The higher the input voltage, the hotter the 7805 will be. Heat is never good for electronics. Speaking of heat dissipation, have a look at the picture of the 7805. Note that the 7805 is mounted with a screw. The screw and the exposed metallic pad on the PCB act as a heat sink. This helps with heat dissipation. Just by seeing this, I assume that the Atari 2600 makes the 7805 hot. Something else to notice is the white substance around the regulator. This is thermal paste and helps move the heat from the 7805 to the heatsink. Techie people recommend that this paste be removed and replaced with new paste. To do this, the screw is removed, the 7805 is moved out of the way by unbending its pins, and then the two surfaces are cleaned. Isopropyl alcohol is a favorite. Once both the back of the 7805 and the PCB are clean, allow dry time. When the surfaces are dry, a final wipe with a clean cloth is recommended to remove any leftover dust or lint. Thermal paste is then applied to the PCB, just enough to make a 1/4-inch dot. The 7805 is bent back to a horizontal position and the screw is replaced. The screw should be tightened enough to press the 7805 against the PCB. This will spread the thermal paste. Just don't over-tighten the screw. First, I measured the input voltage to verify that it was somewhere between 9 and 14 volts DC. I attached the voltmeter's ground to the negative side of the large axial electrolytic capacitor. I then touched the input pin of the 7805. I measured 10.5 volts DC on the input pin. This is great. Just a little above the adapter's rated 9 volts out and below the 14 volts that I read without load. The voltage was steady. So far so good. Next step was to measure the output voltage. This, without exception, had to be 5 volts DC. I touched the voltmeter's probe to the 7805's output pin. The voltmeter registered 5.05 volts DC. This was also great. It was just a little above 5 volts DC, perfectly acceptable. At this point, I knew the adapter and regulator were working fine. Plus, nothing exploded. Ideally, it would have been better to disconnect the 7805's output from the rest of the circuit. This would have been a precaution in case one of the capacitors was defective, or worse, if the 7805 was defective, then the output voltage could have been higher than 5 volts. However, when a 7805 fails, it fails on the side of caution, meaning that it shuts off, so it is very rare that a failed 7805 will damage electronics that are connected to its output. If 5 volts DC is not at the output, then the 7805 has failed and needs replacing. Although we could get another identical 7805, the overall consensus recommends that the 7805 be replaced by the Traco Power TSR-1 2450. This device also accepts an input voltage and outputs 5 volts DC, but it runs cooler and is more efficient. The TSR-1 2450 is pin compatible with the 7805 because it was meant to be a drop-in replacement for it. Since it runs cooler, we don't need a heatsink for it. Recommended. But if the 7805 is working properly, then it is better to leave it as is. Although the dust rings are not necessary for the Atari 2600 to function, I like restoring these classic devices to their original state, or at least as close as I can. The ring seems to be made of foam. It is squishy. I had some foam sheets and located a black one. A closer inspection revealed that the dust ring was very similar to the foam, even in its thickness. I just needed to cut out 2 rings from the sheet. This image shows how similar both materials are in thickness. Even the color matched perfectly. What I needed to do was to cut out an inner and outer circle. I had the scissors on hand, but these were too big for the inner circle. I tested with a hole punch and found that the size made by it was very close to the original dust ring hole size. I just needed to center it correctly. To help, I traced a black circle with a pen. I wasn't totally satisfied with how the outer circle came out. I wanted a smooth cut, but instead got lots of straight cuts. In the end, both new dust rings came out okay. I missed the exact center, so the inner hole was off center by a bit. In retrospect, if I had to do it again, I would first punch out the inner circle, then trace a circle around it using the original dust ring. Finally, I would use the scissors to cut one smooth line following the traced line. Oh well, live and learn. After giving the motherboard a good cleaning, I placed the dust rings on the switches pegs. Actually, these look quite good. I then tested the 2600 and got a display on the screen. Looks like the unit was functional to begin with. Still, it was good that I tested the voltage levels. The next step was to reassemble the 2600. I pressed the video cable back into the guide. Then I placed the motherboard on the bottom part of the case and slowly placed the top part. I carefully aligned the whole assembly on the case to match the switches and connectors on the motherboard. After struggling a bit and tweaking the position, I finally got the cover and the motherboard aligned correctly. I later found out that many assemble the unit upside down. They place the top cover on the table, then place the motherboard, aligning it with the cover. Then they place the bottom part of the case on top of the overturned motherboard. This seems like an easier way to assemble the 2600. Here is the top cover aligned with the motherboard. The front switches and rear components are seen. Oops, while fitting the motherboard to the case, the video cable came out of the guide. I just pressed it back down to secure it. In my opinion, it is important that the video cable be secured. If it gets pulled hard, the guide will absorb the force. If the video cable is loose, then the force will be absorbed by the cable's connector or the motherboard. If the force is great enough, damage to either of these might occur. Once I put in the 4 screws, the Atari 2600 was ready. Future updates can include replacing the old capacitors and adding a composite video interface. Now I wanted to connect the Atari 2600 to the TV again just to be sure it was still working. Originally, many video devices of the 80s came with a TV switch box that connected to the video device and the TV. The switch served 2 purposes. The first allowed the TV to be connected both to the antenna and the video device, be it a computer or, as in this case, a game console. The switch allowed us to easily switch between the device or the antenna. The second purpose of the switch box was to match the impedance of the video device with that of the TV. Most devices, if not all of them, used 75 ohms impedance while the TV used 300 ohms. The device's video cable connected to the switch box, which when selected converted the 75 ohm from the device to 300 ohms of the TV. Modern times are different. There is no TV or display that I know of that still has the 300 ohm antenna input. This means that, for these cases, the switch box is useless. But not all is lost. The coaxial RF input of today's TV expects an impedance of 75 ohms, the same that is generated by the video device of old. In theory, we can just connect the video cable from the device to our new Jetson-era TV. But nothing is that simple. It turns out that the video cable from the video device, in our case the Atari 2600, uses an RCA connector, while the TV always has an RF coaxial connector. Luckily, different vendors sell all sorts of adapters. The one pictured is one such example. The item pictured is an RCA female to RF female adapter. The adapter connects to the RCA connector on the Atari's video cable, and the RF side connects to a coaxial cable that connects to the TV's RF coax in. How the connection is made depends on the adapter. The adapter can be connected directly to the TV, but in that case the adapter must have an RF male connector. In this image, we can see how the male RCA connector from the Atari plugs into the adapter. Since this cable is long, I could have gotten an adapter that connected directly to the TV, but instead I got one that needs a coaxial cable to complete the connection. Yup, it is as easy as that. The picture won't be top quality, but at least we can get something on screen without having to modify the Atari further or get some exotic device that converts the video from the Atari to one of the TV's inputs. Life is good now, but we don't know what the future holds. If TV manufacturers decide to eliminate the RF coax in, then we'll need to find another way to connect the Atari 2600 to the TV, which might imply adding an interface to the 2600 so that it generates a compatible video signal that the TV can use. After hooking everything up, the next step is to configure the Atari and the TV. The Atari has a channel selection switch, as shown here. We can either choose channel 2 or channel 3. Back in the day, it was guaranteed that one of these channels would not be used by any broadcasting network. I selected channel 3. To select channel 3, while the Atari is in front of you, reach to the channel selection switch in the back and slide it to the right. There is a legend that indicates how the switch should be depending on the desired channel, but it is hard to see. In this image, the legend is just above the channel select switch. Here I've added this paper note, which leaves no doubt. Once I selected channel 3, I powered up the Atari and the TV. The next step was to configure the TV so that it would recognize the signal source on channel 3. First test was changing the channel to 3. This was easier said than done because some of these new TVs will only switch to channels that have been previously recognized. No luck with my TV. I opened the TV's menu and made my way to the option that scans all channels looking for a signal. Channels that have a signal are recognized so that the human can switch to them. I got the scan started, which took about 15 minutes. My TV scanned both digital and analog channels. When the scan finished, I selected the RF input as the TV source. This input source can go by many names, such as air, analog, RFN, TV, or antenna, among others I am sure. Once I switched to the RF input, I used my remote to change to channel 3. Lo and behold, the Atari screen displayed. I am now happily playing Space Invaders. A few tips. Make sure the Atari is off when removing or inserting cartridges. Make sure the Atari is on when scanning for channels. Determine how the hookup to the TV will be made before buying the RCA coaxial adapter. Verify that the channel selected on the Atari coincides with the channel on the TV. In any case, the TV might not allow you to switch to the channel if it doesn't coincide with the Atari's selected channel. One last tip, although quite obvious, make sure that when scanning for channels, the Atari is hooked up correctly to the TV. Earlier, I mentioned that my motherboard was revision 16. To check out the revision of the motherboard, have a look at the top left corner. The rev number is below the Atari logo, as it is pictured here. I only have this Atari, so I can't guarantee that the rev number is located at the same spot in all revisions, but it is noticeable, so searching for it is usually successful. This brings this log to an end. I have plans to mod the Atari. Most likely it will be with a composite video interface. But for now, I am happy I got a unit for a few dollars, and I did not have to spend anything to get it restored and cleaned.